In the last class, we discussed temperature entropy diagram of water, the TS diagram. Now here you can see that OA is increase in temperature due to addition of heat to the water, and suppose O is the 0 degree centigrade. O represents 0 degree centigrade. So from O to A, the amount of entropy or amount of enthalpy will be called sensible heat. Enthalpy we will call sensible heat from 0 to A. Now A is the point which we call the saturation point, TS, at which the water starts boiling. That means the formation of steam begins and temperature does not increase, and that temperature is called saturation temperature. Okay, and from A to B it will go on at the same temperature TS, and while going from A to B, that means when we continue our heat addition, then the liquid will become vapor. So this region is liquid plus vapor, and this region is only liquid, but temperature increases. And liquid plus vapor region, that is mixture of water and steam. And as we go from left to the right, that means as we go on increasing heat, then amount of liquid will decrease, but amount of steam will increase. So at point B, all the water will be evaporated completely, and that is called the dry steam. So this is the dry saturation point. This is called dry saturation. And this point is also saturation point, but this is the water point. This is water point. Point A is water at saturation temperature, and point B is dry steam at saturation temperature. Okay, this is very important. After this, you have to understand this thing to have the better understanding of all other concepts. Okay, I repeat, from O to A, this is liquid, but temperatures goes on increasing, and at a particular temperature, heat addition, if we goes on adding the heat, then the temperature will no more increase, but evaporation will begin, and due to the continuous evaporation, the whole water will be evaporated, and it will be at the dry saturation point. So if you look at the point OAB, that means O means water at 0 degree centigrade, suppose, and A is water at 0 centigrade. Now what is the difference? A is at saturation temperature, but O is at 0 degree centigrade. Maybe different also, but we will call it 0 degree centigrade. Now what is B? Same temperature. B is the steam at TS, saturation temperature. Steam at saturation temperature. After this, if we add heat, then the temperature of dry steam will increase, and that we call superheated steam. Say for a particular point C, it may also go beyond this, but we consider one point C, and at this point the temperature is called T sup. That means temperature of superheated steam. And if you look at the axis for the entropy, then SF is the entropy of liquid, and SFZ is the entropy during the evaporation, and T sup, S sup is the entropy during superheat. And if this is heat, total heat or enthalpy, then we will call it HFD. HFG means latent heat of evaporation, and this we will call HF, latent heat of water or liquid. And after this we will call H sup, that means enthalpy of superheated steam. So consider a TS diagram, that means temperature entropy diagram. So same thing we are going to discuss. Suppose we have a quantity, say 1 kg of water at 0 degree centigrade. Temperature may be 0 degree, but we consider the pressure to be atmospheric pressure. Remember, I am telling atmospheric pressure. Then at atmospheric pressure, what is the boiling point of water?
100 degrees centigrade.
Good, 100 degrees centigrade.
100 degrees.
Good. So water will start boiling at 100 degrees centigrade and it will become steam. Completely it will be converted to steam at 100 degrees centigrade itself. So you can observe this. You just look at the screen. Now if we start from point O, that means from say 0 degrees centigrade, and the pressure is say atmospheric pressure, then point OA, what does it represent? Line OA, the increase of temperature of water from 0 degrees centigrade to how much temperature? If it is atmospheric temperature, then this temperature is 100 degree centigrade. So we can say this is Ts. For atmospheric pressure, Ts, saturation temperature is 100 degree centigrade. And suppose we consider this P is equal to, pressure is equal to 1 atm. Atm means atmospheric pressure. Now, let it, yes?
No, sir.
Okay. Line AB, what does it represent? Line AB?
So, TFG.
HFG, okay? HFG means enthalpy of latent heat. So, latent heat or enthalpy of during evaporation. Key represent korise air para B loi jaunte, water starts boiling and steam, amount of steam goes on increasing, and at point P it will be 100% steam. And after this, if we increase the temperature, if we go on heating, then it will be a superheated steam. Now we consider that pressure is equal to 1 atmospheric pressure. Okay. Now just consider if the pressure is more than 1 atmospheric pressure. Suppose we take the water in a closed chamber. Closed chamber means a constant pressure, something P equal to P1, which is higher than atmospheric pressure, and if we keep some water over here, initially we take 1 kg of water, then same thing will happen, the temperature will increase if the pressure is more than atmospheric pressure. First the temperature will increase like OA, and at a point it will reach a temperature, and what is that temperature? At which the temperature will not increase? Saturation temperature, okay? Saturation temperature. Okay, I will draw the line now, okay? You look at the screen carefully. So this line is for say P is equal to P1, and the increase of temperature will be OA1 say. So at this point, this is Ts1, that means saturation temperature of water at P1 pressure. And after that the evaporation will begin and it will go up to the point B1. That means A1, B1 represents latent heat of evaporation, or we can say the process of evaporation. Okay. Then after that, if we add more heat, it will become superheated. So the graph is like this. For pressure, atmospheric pressure, it is different slightly, but at higher pressure, the graph is like this. O, A1, B1, and they say this is C1, and in this case, this is C. Now we consider even higher temperature. Okay, P equal to P2 now, higher than the previous temperature pressure. Now what will happen? You look at this screen. Now at this, in this case, the OA2 say, this is the increase in temperature due to addition of heat, and AB2, this is evaporation of water at what temperature? Pressure we have already mentioned P2. So this temperature is TS2. That means saturation temperature for pressure P equal to P2. And that's it. So what we have observed, if we increase the pressure, pressure will be constant. But if we increase the pressure, for higher pressure, the evaporation or increase in temperature takes place, or we can say formation of steam is like this. So at O it is 0 degree centigrade, at A1 it is water, saturated water, that point we call saturated water. Also OA1, this line is called liquid line, because throughout this line the water is liquid and there is no vapor at all. But from A1 to B2, A2 to B2, the water will be evaporated. That means amount of water will decrease and amount of steam will increase. And at point B, that is 100% steam. So this way it can go up to C2. So BC, these are, or B1C1 or B2C2, these are superheated steam. Okay, the diagram is for temperature entropy, temperature versus entropy. Now we consider another pressure higher than P2. So say A3, B3, and this will be C3, and pressure P equal to P3, higher than this. And in this case, the saturation temperature is TS2. Okay, same thing. Now we'll show you even higher pressure. So this is another pressure. For this we'll name it A4, B4 and C4. And what is the pressure? P equal to P4. And saturation temperature is what? Higher, boiling point. What is A? A points are boiling point of water. And this temperature is called TS2. That same boiling point of water, we call it saturation temperature of water. Okay, same temperature. Now we can increase the pressure even more. So in this case, you can observe this thing. In this case, A4 and B4 are same point. Same point. That means if you go on increasing the pressure, there is a point at which the B and C point, A and B point will coincide. That means if you go on increasing, what decreases? If the pressure increases, then what decreases?
Latent.
Excellent. Latent heat goes on. Yes, very good. So latent heat goes on decreasing. And at a pressure, say P5 or whatever be the pressure, at that pressure, this is Ts, and this pressure and temperature is called critical pressure and temperature. So what is the critical thing about this? That the water, what is this? Critical point, at critical point, and the point is called the critical point. Okay, at critical point, that means at higher pressure, there is zero latent heat. There is no latent heat. Then what is the thing? The water is directly evaporated to superheated steam. So this is C. Sorry, I'm sorry. I should have written it 5. This is not 4 actually. So it will be 5. A5 as well as B5. So this is an interesting thing. Now you observe, if we construct a line joining all the points A, A1, A2, A3, A4, A5, these points are what point? I have already mentioned. This is what line? A liquid line. Very good. So this is called liquid line. And again, if we join the points B, B1, B2, B3, B4, B5, this line is called dry steam line. Remember, dry steam line. So I will draw the line, okay? I will first draw the liquid line. So I will draw it above these points itself. It will be a white line. You look at this. Not white, blue. Okay. This line is, now this line is, we call it liquid line. Okay. Now join the points B5, B4, B3, B2, B1 and B. And you see, I will draw a red color line to represent the dry steam line. Okay, so what is this line? This line is dry steam line. And dry steam line is also called saturated steam. And liquid line is also called saturated liquid line. So there are two lines. One is saturated liquid line and another is saturated steam line. And if you go towards the right side of dry steam line, then what is that region? A whole region will be what type of steam? Yes? What type of steam we will get? Superheated steam. Very good. So this will be superheated steam. Good. And if we go towards the left side of the liquid line, what we will get in this region? In this region, what we will get? You can see a laser point. In this region, keep up, mommy. If we go towards the left, you see this line is liquid line. So if you go towards the left of the liquid line, then what it will be? Definitely it will be liquid. Okay. So this is liquid region, it whole region. Now the question is, what about the region between liquid line and dry steam line? What is this region? This is liquid plus vapor region. So we have get some interesting thing. Then this curve represents the region in which the steam will be mixture of water and vapor. It also gives the region in which steam will be superheated, and it also gives us the region in which the steam will be not steam but water. And we got some line O, A, A1, A2, A3, A4 and A5. This is the liquid line. And B5, B4, B3, B2, B1, B and so on, this will be the dry steam line. Okay, we will try to understand. And this is the line joining all the points, liquid point and dry steam points. And this, what is this point C? Can you tell me? Excellent. So this is called critical point. And the temperature at critical point is called critical temperature. And the pressure at critical point is called critical pressure. Then what is the characteristic of the critical point? The steam is directly converted to superheated steam. There is no any liquid vapor mixture. It will be remain liquid, 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 and instantaneously it will become superheated steam. That is the characteristic of critical point. And please remember, it will be very interesting. In the next semester, we will study the formation of steam, how to generate steam generation in a boiler. And nowadays, all modern boilers works on critical temperature and above critical temperature or above critical point. That means the steam is produced at very high pressure. So if you look at this pressure P1, so we go on increasing the pressure, and at this pressure, this is the critical pressure. And that means modern boilers are very high pressure boiler. Okay, all modern boilers are high pressure boiler. Then what type of high pressure? It works above critical point. Okay, fine. Water region. Right? The left side of this is called water region, and right side is superheated region. Region of superheated steam, region of water, liquid, and the middle portion is liquid, region of liquid plus vapor. We can also show it like this. Now you see. So what does this represent? This is O, this we call C, critical point. So these are the point A, A1, A2, A3, A3 like this. And these are the point B1, B2, B3 like this. And this is liquid plus vapor. And this is superheated steam. And this is only liquid. And from this point to this point, if you go towards the right side, okay, sorry, this way, so at this point it is 100% liquid, and at this point it is 100% steam. So liquid keeps on transforming to the vapor phase. That is called the phase transformation. Now you see the region I am going to show. So this region, what is this region? Whole region is liquid region, and this line is liquid line. Liquid line, and this region is region of superheated steam. Okay, and this line, only the line, not the region, this is called dry steam line. This is also known as saturated steam line. Okay, and this line is also known as saturated water line. Now if you can try to answer one question, suppose I consider this line O, A, P and C. Now in the last class we discussed about dry steam and wet steam. What is a dry steam?
100%
Very good, excellent. So at point B we can say this is 100% dry steam. Now in the last class we also discussed about dryness fraction. And dryness fraction dF is the ratio of dry steam divided by liquid plus vapor, total. So we consider 1 kg of steam, in which there will be some liquid and some vapor, and this vapor means dry steam part. Now at point B, what is the dryness fraction of this steam?
1.
Very good. So I will write 100% dry steam. We will not go on writing 100% steam every time. So we will write X is equal to 1 because dryness fraction dF is, we call it X. Universally it is called X. So at point B, X is equal to 1. Now what about point A? Dryness fraction Very good. So if we write at this point x equal to 0, then also it is okay. And in between a and b, value of x is greater than or equal to 0 and smaller than or equal to 1. When it is 1, the steam is 100% dry, and when it is less than 1, then steam is wet steam. Okay, so now, so this liquid line, this line up to this point C, critical point C, simply we can write x equal to 0. That is enough. Everybody will understand. What is x equal to 0? That means we are telling that this is the liquid line. And this line from C onwards, this we can write x equal to 1. That means we are telling that this is the dry steam line or saturated steam line. And if we write in between x is 0, 1, we are telling that these are liquid plus vapor, this is liquid region, and this is superheated steam region. You have to understand the thing. Okay, so I am going to recap only some things. Sensible heat of water, then latent heat of vaporization, then total heat H. These three things we have already discussed. Okay, so this is a TH. What is H? H stands for what? Heat. Total heat you can say, and more appropriate term is enthalpy. Okay, enthalpy. So this is enthalpy. Good. So temperature enthalpy diagram. Okay. From this is temperature T naught. We consider that temperature is 0 degrees centigrade. That we represent by T naught. From T naught to Ts, say OA, this is liquid line. And during this time, what amount of heat or enthalpy is required? OA, small a, okay? OA is what? OA is, and this amount of heat is actually, it is called HF, and HF is for sensible heat. So we discussed it in the previous classes. HF is sensible heat. So this we will call HF. That means from we just imagine we are heating some water at some pressure. This time we are not mentioning what the pressure is, at any pressure from 0 degrees centigrade. So at some point A, the temperature increase will stop. Up to that point we have to add some heat, and that amount of heat is called sensible heat of water, HF. Okay, this is sensible part. We can sense, we can see, we can measure the increase in temperature. Now after point A, sensible heat is what? Amount of heat required to increase the temperature of water from 0 degrees centigrade to Ts degrees centigrade, and Ts is what? Boiling point of water or saturation temperature of water, anything you can say. Ts is saturation temperature of water. Also Ts is saturation temperature of dry steam, same temperature. Now suppose we increase the temperature to point B. So from A to B, we will represent it like this. Say this is point B. This amount of heat H, H means enthalpy. This is called what? HFG. HFG. What is HFG? What is HFG? The latent heat of vaporization.
Latent heat, vaporization.
Good. Latent heat of vaporization. So this is process is called vaporization. From A to B, the amount of heat is HFG. And after this, if we add more heat from this point, that we'll call heat enthalpy or heat, whatever you say, enthalpy of superheat, or simply we can say superheat. So that is the thing. Now there is another term that is called the total heat. Now what is total heat? In this case you remember this point O is at 0 degree centigrade. So from O to A, if we measure from 0 degree centigrade to any point, that is called total heat. But if we say A to B, that is not total heat. Now you tell me, what is the total heat at point B? Can anybody tell me? Total heat H at point small b, okay? Small b and capital B same thing. Small b, what is this? H equal to?
Sir, the plus P will go.
Yes, excellent. So that is the thing.
HF plus HF0.
HF plus HFG. So what is total heat? যেতিয়া আমি total heat mean কৰো, that means 0 degree centigrade or পৰা যিকোনো point, any point. Now someone tell me, what is the total heat at point small a? At small a total heat কিমান? H equal to কিমান?
Sir, HF.
Yeah. Yes, very good. That is HF. 0 পৰা গৈছো. Now at point B dash, suppose this is point B dash. So this we will call B dash. Now you tell me, what will be the total heat at point B dash? At point B dash, total heat H equal to what? This plus this. So HF, we can say HF plus AB dash. What does the AB dash represent?
Wet.
Good. So this is wet steam. This is dry steam. And this is saturated water. So I think this is enough for today, okay? Because in the next class we will see what we will call this total heat at point B dash. That we will discuss in details. Total heat at different point. You see, this is a point in between saturation temperature. Ts is saturation temperature, but this is not saturation temperature. So we will call O to A, that is the total heat at point A. And for this is B, and this is definitely HF. And at this point, this is HF plus something. And at this point, this is HF plus HFG. And what is this? And one thing you remember, at point D, what is the total heat in this case? You tell me, already you have told, what is total heat? H.
HF plus HFG.
HFG. And this is also called the Hg. Total heat of dry steam is represented by Hg, and which is equal to HF plus HFG. That's it. G stands for gas. That means 100% gas. At point D, steam is gas. But before D, that is not gas. Mixture of gas and liquid. That is why it is called Hg. So that one thing we got. Hg equal to HF plus HFG. So you just tell me once again, what is Hg? Total heat of dry steam. What is HF? Total heat of water at saturated water, or simply we can say sensible heat. And what is HFG? Latent heat of vaporization.
Vaporization.
Yes, good.